Hello and welcome to this video about the center of gravity. So the center of gravity, what is it? It's actually the place where you should support an object such that it balances. Although sometimes the center of gravity is not inside the object, and of course you can't support it there. But let's keep things simple. If I have a triangle like this, actually, and I suppose it's more or less the weight is homogeneously divided, then it should be at about 1/3 of the symmetry axis. So it should be more or less here. I'm of course going to fail even if I try, but yeah, I know. At least I tried. So that's the point of gravity. But we can make things a bit more complicated and we can put weights on the edges of the triangle. Now we're going to suppose the triangle itself is weightless and it's all about those weights at the corner. And then you can wonder what happens to the center of gravity. It will probably shift a little bit here. Now these 1, 2 and 3 are not only to indicate the number of the weight, but also the weight itself. So this is 1 kilo, this is 2 kilo, this is 3 kilos. And if I would have to guess, since here's the 3 kilos, I would think the center of gravity would probably move to somewhere over here. So the question is, how to compute exactly where it is? Now let's call this vector towards this point r of g with a little arrow because we think of it as a vector. R of g. The challenge is to compute this. And of course I have all these other position vectors. So this is r1, this is r2, and this is r3. And I have the weights because the weights are actually the numbers that indicate it. Now the formula to compute the center of gravity I just threw here on the light screen, and yeah, there it is. Let's try to understand this a little bit. Well, first of all, there's a capital M here. The capital M is just the sum of all the mass. So in this case, that's actually 1 plus 2 plus 3. It's 6. And then you have to think of it as follows. The proportion of the weight sort of determines how much the center of gravity shifts towards the point where that weight is positioned. So if I look at this in this way, this is the total weight. So m1 divided by the big one is the proportion of the weight m1 compared to the whole. And it adds to this amount to the total position. It's the position r1 times that proportion. And then the addition of r2 is determined by m2 divided by the total weight. And the addition of m3 is decided by m3 divided by the total weight. So that's how you do it. And actually, it's the same formula that you would use if you want to compute your grades. If you had 5 grades, but the test had different weights, like 1 and 2 and some 1 again. So then you use the similar formula, but then just with numbers and not with vectors. So the point here is that we do our calculations by multiplying numbers with vectors. So that's also illustrated through this task. So there you go. Let's plug in the numbers and let's see where that center of gravity will end up. So we have the position vector for the center of gravity equals 1/6, right? We established that, times m1. m1 is simply 1, times the position vector of 1. So that's 4, 1, 0. So I get the scalar number times a vector, plus, well, the weight of the second, that's 2. And the position vector here is 0, minus 4, 2, or negative 4, if you care about that. And then there's m3, that's the weight of the third, which is simply 3, and the position of it is 0, 7, 2. So now let's practice our computations with vectors. First of all, let's keep the 1/6 here, just where it is. 1 times this vector is simply 4, 1, 0. It's the same vector. 2 times this vector means 2 times each of the coordinates. So it's 2 times 0, which is 0, 2 times minus 4, which is minus 8, 2 times 2, which is 4. And that's it. Now the last one, we get 3 times 0, which is of course 0, 3 times 7, which is 21, and 3 times 2, which is 6. and then the big bracket to close the whole thing off. And now we add up these vectors, which you do also per coordinate. So let's do it. I will get 4 plus 0 plus 0. That's the first coordinate. Oh, I didn't need that extra bracket, did I? Because we're going to be done after this. Yes. And then the second, that's 1 plus minus 8 plus 21. Plus 21. And then the last one is 0 plus 4 plus 6. Okay, so far so good. Now let's actually compute the outcome of those sums, which will be 14, and finally 10. And then I have another scalar multiplication, so that will be 4 over 6, right? I just multiply the first number by the scalar, and then the second number by the scalar, and then the third number by the scalar. And that will be also 6. I could simplify a little bit those fractions, I think. So it's 2 over 3, it's 7 over 3, and it's 5 over 3. Now, it's always good to see if your answer makes sense. So this moves definitely a little bit in the x direction, only a little bit. It moves quite a lot in the y direction, and then a little bit up. It's amazing. I end up more or less where I thought our center of gravity would be. So we're very happy, and we know how to compute centers of gravity, and we've practiced a little bit how to make computations with vectors multiplying with scalars and adding them up. So that's it. Thanks for watching.